Bismillahirrahmanirrahim. This is Dr. Naushin Tariq Siddiqui, and we are going through the course Physical Pharmacy, course number 315. We were doing the physical-chemical processes, and in which we have started the miscellaneous processes, in which we have already done some of the common processes which are used in pharmacy. Today, we are going to start with 5 more different processes. These are ignition, sublimation, fusion, calcination, absorption, and decantation. As I've told you that these processes seems very easy, and they already know many of these, but now we are doing this in the context of pharmaceutics. And they are used in the manufacturing process of tablet or suspension or any pharmaceutical preparation. And they are very important to keep in mind and to have a clear concept. The first process which we are going to do today is ignition. It is also known as inclination. Inclination means burning to an extent that it is wholly burnt or it is all in flame. It is a process by which an organic substance is strongly heated until whole of the carbonaceous matter burns and an inorganic residue known as ash is left behind. Ignition is a process where the whole of the organic material, it gets strongly heated, or it gets burned until all the carbonaceous matter which is present in it burns completely, and the residue is known as ash, which is, if you take a constant amount of any substance, then the ash would be constant for that particular substance. And if it's not, then you can know that the compound is not pure. This is a process of heating the organic substance in excess of air until all the carbon atoms have burned as carbon dioxide and residue of inorganic matter is left behind. The residue is called ash and the process is called ashing. On laboratory scale, ignition is carried out in silica or platinum crucibles. If we go through the formal definition, then it is said that the process in which synthetic compound or drug is burned at high temperature on an electric furnace to remove the organic substance and left behind the inorganic substance. So the organic substance is going to burn, all of the organic substance is going to burn, and we will left behind with an inorganic substance which is known as ash, and the process is known as ignition. There are certain times when whenever these compounds burns or any compound burns, it usually burns if it contains carbons, but it has other products as well. And certain times when the compounds are ignited, other byproducts are also formed. So the phenomena depends not only on the compound, but also on the bicompounds, the byproducts which are forming during the ignition process. So it is very particular for particular substances. We know how particular substances ignite and how they, what they give, if they give good flame or not. Certain little explanation of the definition. Known quantity of substance is ignited in silica crucible, that is in an electrical furnace. The substance is ignited at specific temperature for definite time in electric furnace, and it remains constant for a pure compound. Okay. After ignition, the crucible is placed in a desiccator containing a suitable desiccant, which is desiccant is a moisture absorbent, and allowed to cool for 25 to 30 minutes. The crucible is weighed. The crucible and the contents are again ignited at the same temperature for 30 minutes. The ignition is continued and repeated until constant weight is obtained as inorganic ash. For its application, ignition is used for standardization and purification of chemical compounds, like, for example, zinc ointment on ignition leaves only zinc oxide. The process is also used to determine the sulfate ash in which ignited substance is H2SO4. This process has limited application, but it is used in many cases, such as zinc ointments. It consists of strongly heating, that is ignition, a sample of the material at a specified temperature, allowing volatile substances to escape until its mass ceases to change. This may be done in air or in some other reactive or inert atmosphere. What is the process? The simplest test typically consists of placing a few grams of the material in a tart pre-ignited crucible and determining its mass. Basically, what you do, you take a sample, and you don't have to take a lot of sample. You take a small quantity of sample, only a few grams, and then you place it in a tart pre-ignited crucible. What is a tart? That is, you have weighed that, and then you, and determining its mass, placing it in a temperature controlled furnace for a set time, cooling it in a controlled atmosphere and remaining and redetermining the mass. When you burn it at a constant temperature for a fixed interval of time, then you take it out, then cool it, and then you redetermine the mass, that what happens to the mass. Application, this process is mainly used for the standardization of organic substances and true drugs by means of granulometric analysis, used to determine impurities of organic salts of alkali metals such as tartrates, citrates, benzoates, and many drugs. Purity of a drug is determined by its ash content, which is constant for pure compound. The next phenomena is sublimation. We are going to discuss what is sublimation, how substance undergo sublimation, advantages and disadvantages of sublimation, and iodine is an example of a substance that undergoes sublimation. I think you all have a clear idea what is sublimation, but still we are going to reconsider it, or we'll read it again. Sublimation is the process where a solid changes from a solid to a vapor, and it does not go through a liquid phase, basically. So in sublimation process, the solid changes from a solid to a vapor directly, and it does not pass through the liquid state. How substances undergo sublimation? Again, the main point is the triple point, which in the phase diagram, which you have seen. Sublimation is an endothermic phase transition that occurs at temperatures and pressure below a substance triple point in its phase diagram. In thermodynamics, the triple point of a substance is the temperature and pressure at which the three phases, that is the gas, liquid, and solid, they coexist in thermodynamic equilibrium. Means that they exist in a equilibrium state at that point. So the sublimation occurs when कब होती है? जब sublimation, जब आपकी sublimation endothermic phase transition के अंदर चली जाती है, that occurs at temperature and pressure which is below to a substance triple point, and this triple point is different for different substance. So whatever substance you are taking, then the sublimation will occur at a temperature that is below that the substance triple point. A phase transition in which a solid is converted to a gas without passing through an intermediate liquid phase. This you can see the normal the triple point of solid, liquid, and gas. Dry ice is actually solid frozen carbon dioxide, which happens to sublimate or turn to gas at chilly -75 °C. The fog you see is actually a mixture of cold carbon dioxide gas and cold. Humid air created as the ice melts, it means sublimates. you have seen dry ice, and you have seen that in normal temperature, it gives foamy-like or fog-like air, or it sublimates to a foggy type of thing. This is basically the dry ice converting into gas, or it's melting, but it melts because it melts at minus 78. It goes into, it turns into gas even at minus 78.5 degrees centigrade. So the fog you see is actually the mixture of cold carbon dioxide gas and cold. And how does iodine sublimize? Iodine is an example of substance that undergoes sublimation. If you put iodine crystals in a test tube, what happens? The outer test tube contains solid iodine that is being gently heated. The inner test tube contains liquid water and ice. The iodine crystals at the bottom of the outer test tubes change directly to iodine vapors on heating. When the vapor reaches the cool surface of the inner test tube, it goes directly from the gaseous to the solid state. Advantages of sublimation. The main advantage of sublimation is for purification process. The minimum amount of product is lost during sublimation, and solvents are used. In this process, there is no solvent use. Most traces of any solvent in compounds are effectively eliminated. When the substance weighs less than 100 milligrams, the best method for purification is sublimation. Disadvantages of sublimation: recovery may not be complete, the fumes may be blown away, and non-sublimate agents may decompose under heat. The next phenomena is fusion. Fusion, it is the process by which the solids get converted into liquid without the addition of any solvent. This process, solids basically converts into liquid without the addition of any solvent. It just converts into liquid. Now, in other words, it is defined as a process of heating the solid until they melt. In a pure crystalline solid, the process occurs at a fixed temperature called the melting point. An impure solid generally melts over a range of temperature below the melting point of the principal component. Amorphous substance such as glass melts by gradually decreasing in viscosity as temperature is raised, with no sharp transition from solid to liquid. So the amorphous, which are non-crystalline substances such as glass, you have seen glass, must have seen glass, which gradually decreases in viscosity. When the temperature is increased, the glass gradually basically melts, and it has no sharp melting point, and it does not melt very sharply, and there is a transient time between going from solid phase to liquid phase. The structure of liquid is always less ordered than that of the crystalline solid, and therefore the liquid commonly occupies a larger volume. Thermal fusion of a given mass of a solid requires the addition of a characteristic amount of heat, the heat of fusion. In the reverse process, the freezing of the liquid to form the solid, the same quantity of heat must be removed. The heat you have given, you have to remove that heat, and the reverse process will occur. The heat of fusion of ice, the heat required to melt 1 gram is about 80 calories. This amount of heat would raise the temperature of a gram of liquid from freezing point. Okay. In the reverse process, the freezing of the liquid to form the solid, the same quantity of heat must be removed. Application. Fusion is done to purify certain solids and semi-solid substance. Example, substance like beeswax, hard paraffin, soft paraffin, and wool. These substances, they do not get degraded with high temperatures. So, To purify these substances, first you melt, heat and melt, and then filter to remove the impurities. Beeswax, hard paraffin, soft paraffin, and wool fat are heated to melt and filtered while hot to remove the dissolved impurities. Then cooling is done to obtain a product free from dissolved impurities. This method is also applied to the preparation of ointments when they contain solids and semi-solid in the formulation. All the substances are first molded and then cooled slowly with constant stirring until a uniform product is obtained. To avoid overheating, the substance with higher melting points are first, to which substances are melted first, to which substances with lower melting points are added. First, we melt the higher temperature melting points with higher melting points, and then the lower melting points are added. Fusion, if we go through that again and we explain it more. Fusion is the process by which the solid gets converted into liquid without adding any solvent. It may also be defined as a process of heating a solid until they melt. Fusion is done to purify certain solids and semi-solid substances like beeswax, hard paraffin, soft paraffin, wool fat are heated, melt, and they are filtered to remove impurities. The next process is calcination. Calcination is a process in which the inorganic substances are strongly heated so as to remove other volatile contents and a fixed residue is obtained. On laboratory scale, calcination is done in silica or platinum crucible, whereas in industrial metallic vessels are used. In this substance, the inorganic substances are strongly heated to remove their volatile contents. Explanation: in process of calcination, the products are obtained by heating the substance, especially ores of minerals. The principal ores which can be calcinated are oxides, carbonates, silicates, sulfides, and halides of material. The gases formed during the roasting of ores, especially sulfides and arsenic, fumes, etc. The gases are formed when they are basically the calcination process applies. The ore is added into one end, which is then shifted towards the firebox and removed after 3 hours. Magnesium carbonate is roasted, or calcinations gives magnesium oxide. This is these are few examples: magnesium carbonate, ferric sulfate, and copper sulfate. Ferrous sulfate. Application: the process is used for the manufacturing of inorganic compounds from natural sources, that is formation of magnesium oxide, which are used as an antacid. Now, adsorption. You already know what is adsorption and absorption. Absorption, and adsorption is similar, but it's a little bit different. What is different? Adsorption is accumulation of molecules on a surface in contact with an air or water phase. It can be in gaseous can be the surface can be in contact with air or with water or a liquid phase. Adsorption is adsorption is dissolution of molecule within a phase, that is within an inorganic phase in contact with an air or water phase. While adsorbent material being adsorbed, only adsorbent material doing the adsorbing, example are activated carbon or ion exchange resins. This ion exchange resins you use in chromatography in different processes, while activated carbon is sometimes used for detoxification. This is a common, this is a picture I've got from internet, and you can see what is absorption. It's going inside of the body, and the adsorption, it's only going, it's only on the upper side of the body. This is the simplest you can say the trigonometrical representation of adsorption and absorption. Now there are two more phenomena in adsorption. These are physio-isorption and chem-isorption. What is physio-isorption or physical adsorption? Is a type of adsorption in which the adsorbate adhere to the surface only through van der Waals forces, that is weak forces interaction, which are also responsible for non-ideal behavior of real gases. While chemosorption is the kind of adsorption, the gas molecules or atom are held to the solid by a chemical bonding. In physorption, basically the two compounds are held together by weak forces, while in chemsorption, there is a chemical bonding occur and which is more stronger than physorption. What are the factors that involve adsorption? Okay, this adsorption are of different types, and they basically depend on different types of there are laws in which they basically depend upon, because certain times the absorption is very good and certain times you need good adsorption. But how can you confirm or how can you make those adsorption with perfection? Because there are certain factors which you can see, which you also must have in mind, but there are certain, because you don't know that the surface which is adsorbing is uniform, and you don't know that all the adsorption to all of the side is equal. This is also very important to keep in mind, that the adsorbed material should not interact with the material you are adsorbing it, and all adsorption should occur with the same mechanism and there is no other mechanism, and all the maximum adsorption only a monolayer is formed, because you don't want a continuous, a very thick layer, so you need a monolayer. So the laws, which governs these govern this phenomena, basically this depends on these things, that these all things are constant and they are clear. Then there are different laws, and there is a graph as well, which which you can plot, and which you can from which you can know that what type of adsorption is done. But I'm not going into the details of those graphs. I'm only right now trying to clarify what are the different types of processes which are involved. Later, when we are doing the more in-depth analysis of or making pharmaceutical preparations, we can go into the details. Absorption of gases by solids. The factors involved are the adsorption and surface area, nature of gas, heat of adsorption, reversible character, effect of temperature, effect of pressure, thickness of adsorbed layer of gas. Now some details how they are influenced: absorption and surface area. Absorption being a surface phenomena, the extent of absorption depends on the surface area, of course. Increase in the surface area of absorbent will increase the total amount of gas absorbed. That doesn't mean that we are going to increase, if you need anything to adsorb, we will increase its surface area. We'll give a fixed or a certain surface area, of course. Nature of gas, the amount of gas adsorbed by a solid depends on the nature of the gas. In general, more easily liquefiable gas is more readily absorbed. What type of gases have good adsorption onto a solid? The gases which are easily liquefiable. Heats of adsorption. Heat of adsorption is defined as the energy liberated when 1 gram mole of a gas is adsorbed on the solid surface. In physical adsorption, gas molecules concentrate on solid surface, thus it is similar to the condensation of a gas to liquid. Therefore, adsorption, like condensation, is an exothermic process. Reversible character, physical adsorption is reversible process. It should be a reversible process because it is not basically not reacting with the material, it's only making a monolayer. The gas adsorbed onto a solid can be removed under reverse condition of temperature and pressure. Means at what temperature you have adsorbed the material, you reverse those conditions and you can get the gas out of the material. Effect of temperature, physical adsorption occurs rapidly at low temperature and increases with increased temperature. Absorption, like most chemical changes, generally occurs with temperature. Thus, rise of temperature can often cause physical adsorption to change to chemabsorption. If you the physical adsorption, you can, the chemabsorption can change to physical absorption if you change the temperature because it starts to react and it can make a bond. Effect of pressure. Pressure leads to increase of adsorption and increase of pressure causes desorption. Pressure increases adsorption while the decrease of pressure can cause desorption. Thickness of adsorption. Absorbed layer of gas, the physically absorbed gas forms only one molecular thick layer. However, above a certain pressure, multicellular thick layer is formed. Some common example of adsorptions are silica gel packets absorb moisture from packed electronic or optical equipments and carbon filter to deodorize drinking water. In pharmacy, activated charcoal is considered to be the most effective single agent available as an emergency decontaminant in the gastrointestinal tract. When somebody ingests any toxic material, then charcoal is supposed to be the best and the most effective single agent, which is you can give in emergency. It goes inside and then it absorbs the material and it comes out from the body because it does not get absorbed in the body. It absorbs the toxic and then comes out from the body. It is used after a person swallows or absorbs almost any toxic or chemical. Absorption is usually described through isotherms. This is functions which connect the amount of absorbate on the absorbent with its जो isotherms है ना, इसके there are four समझ लें कि इसके four types हैं isotherms के और four graphs are there which explains the isotherms. मैं अभी आपको सबसे पहले यही कह रही थी कि जो laws हैं जो ये हैं इसको हम describe अभी नहीं कर रहे unless we do some preparation in lab कि हम कहीं करेंगे तो then I'll explain to you that in इसमें जाएंगे. ठीक है. One can find in literature several models describing process of adsorption, namely ये जो सारे हैं ना ये जो Frangelic isotherm, Langmuir isotherm, BT isotherms, they have different, they explain different type of adsorptions. किस तरह से किस पे क्या effect हो रहा होता है और adsorption कितने types की होती है. Application of absorption, we have go through certain absorption. There are certain more. Production of high vacuum. If a partially evacuated vessel is connected to a container of activated charcoal cooled with liquid air, the charcoal adsorbs all the gas molecule in the vessel. This results in a very vacuum. It basically aids in the production of high vacuum because when you have already created a vacuum in a vessel, if you connect that vessel with a charcoal cooled container, then this charcoal, they absorb the remaining amount of the air in the vessel and this result in a very high vacuum. Gas masks are devices containing an adsorbent which has activated charcoal in it. You must have seen a gas mask in which you have seen a protrusion coming out of the mask. So it has activated charcoal or a series of adsorbents. These adsorbents remove poisonous gas by adsorption and purify the air for your breathing. Heterogeneous catalyst. In a heterogeneous catalysis, the molecules of the reactant are adsorbed at the catalysis surface where they form an adsorption complex. This decomposes to form the product molecule, which then take off from the surface. Number 4 is the removal of coloring matter from the solutions. Animal charcoal removes colors of solution by adsorbing coloring impurities. Thus, in the manufacture of cane sugar, the colored solution is clarified by treating with animal charcoal or activated charcoal. Chromatographic analysis. This is analysis basically you will do in after, I think, in your third year. We'll do this chromatographic analysis. Then these are analytical procedures. Mixture of small quantities of organic substances can be separated with the help of chromatography, which involves the principle of selective adsorption. Decantation. This is the last process. Basically, sedimentation, decantation, and filtration. These are some of the processes to purify something. Okay? So these are kind of interrelated. First, if you, for example, if I give you mud and water, first what you will do, you will keep the mud and water aside and you will see that the mud is going to sediment. After sedimentation, what you are going to do, you are going to pour the remaining liquid over the surface of the sedimented particles. And that process is basically called decantation, and then you filter it out. So decantation is what? Decantation is a process for the separation of mixture of immiscible liquid or of a liquid and a solid mixture such as suspension. Immiscible liquid separation takes advantages of difference in densities of the liquid. A separating funnel is an alternative apparatus for separating liquid layers. It has a value at the bottom to allow drain from the bottom layer. It can give a better separation between the two liquids. For example, separation mixture of oil and water. What you do if you take one oil and water mixture, okay? If you keep it aside, then the oil and the water, they separate out. Usually what you do, you decant the oil layer and the water layer. But to make it more clear, a separating funnel was devised. What it do that it makes two layers in the separating funnel and it has an opening below the funnel. So you can easily, open the funnel and you can easily take out what is heavier, heavier. It comes out first, and what is lighter, it will comes out after. Okay. So, but if you don't have that, then you can use the decantation process. Takes advantage of gravity, sedimentation of solid in case solid liquid separation, sedimentation, and I have already told you that what is sedimentation, but the tendency of particle in suspension to settle down in the fluid due to certain forces like gravity, centrifugal acceleration, or electromagnetism is called sedimentation. A solid that gets settled down is called a sediment. In laboratory, it can be done in test tube. To enhance productivity, test tubes should be placed at 45-degree angle to allow the sediments to settle at the bottom of the apparatus. A decanter centrifuge may be used for continuous solid liquid separation. Liquid solid, basically, centrifuge, what it does, it also helps in the solid gets deposited in the bottom and you can easily take out or decant the upper portion or the upper layer of liquid. Example in an application, decantation is frequently used to purify a liquid by separating it from suspension of insoluble particles. Decantation is also present in nanotechnology in the synthesis of high-quality silver nanowire solutions and fabrication process of high-performance electrodes. Decantation is also being applied, which greatly simplifies the purification process. Fat is determined in butter by decantation, and sugar industry processing of sugar beets into granular sugar. Many liquid solid separations are encountered. So decantation is a frequently used phenomena or process. Okay. Thank you very much. This is all for today, and later we are going to study our remaining 6 miscellaneous processes in our next lecture, inshallah. Thank you very much.